So, I mean, today's episode is about intro to data analytics with R, but I'll leave that for Paulina to describe and elucidate in detail. But just a very short story on how I came across Paulina, because for a lot of the other guests that have been on the show, I either have met them in person, either we work professionally, or we met on LinkedIn, right, which is a great professional networking platform. However, for Paulina, I was browsing Coursera, and if you're on my LinkedIn, I, gave the story a bit in more detail. But I was browsing Coursera, and I saw her there with the redacted back last name. So I only had like Paulina to go with pretty much. And I scoured the web, until I found an article on her story, right? On a Ghanaian news media. So from there, I linked up to her on LinkedIn. So yeah, and here she is, and I can't wait for her to share her story. And I was mentioning in my LinkedIn post how it's very, very important for data professionals to have Googling skills. I mean, if I didn't have that, then Paulina wouldn't be here today. So without further ado, right, I'm happy to present to you Dr. Paulina. Yeah.
Hello, everybody. I don't know why Toby keeps giving this grand story. It makes it sound like I'm some big shot, but no. Okay, so today we are going to talk about data analytics in R. We're not going to go into too much detail because I know we are coming from diverse backgrounds. We have those who have no programming experience. We have those who do not know anything about data analytics at all and are just curious. So I'm going to try and make it suitable for beginners. Yes, so if you are an expert, bear with us. Yeah. Okay, so I'm just going to share my screen.
And by the way, feel free, right, Boadiwaa, to introduce yourself and all the interesting work you're doing at so you don't just jump into all this complex. So yeah.
Okay, so I'm Boadiwaa. I'm a medical doctor, and I'm also into data science and bioinformatics. And that should explain why I use R, because R is mostly used by bioinformaticians and academicians and statisticians. Yeah, I'm interning at the Kumasi Center for Collaborative Research into Tropical Medicine. So we use both Python and R, but my group, we tend to use a lot of R. Yes. So I actually did study Python as I think I first started programming in C++. Then I dropped off a little bit, and then I studied Python. But in my current job, I use a lot of R. So that's why today we're going to talk about R. I'm also a beginner, so we'll be learning together. Yeah. So can you see my screen? I'm sharing some slides. Okay, so we're gonna go through R. I'm going to start with like a brief introduction. We're gonna touch on the basics that are across board when it comes to programming. So, but I'm not gonna go into too much detail. We'll just look at those that are relevant for data analysis. And then we're going to go to RStudio and try and play around with some data. So yeah, this is our outline for the day. So R comes from the names of its developers, Robert and Ross. So that's where the R comes from. And also it's a play on its parent language, S. So R is modeled after S, which is its parent language. And R is a functional programming language as opposed to Python, which is more object-oriented. So this is for those who know a little bit about programming. But for beginners, you should just know that in fact, everything that happens in R happens via a function call, and everything that exists is an object. So functions are like the main thing in R, and you can do with an R function whatever that you do with any other object. So you can pass it to variables, you can store them in lists, you can pass them as arguments. Some of these terms are like programming terms, but as we move on, I think it'll become clearer. Yeah. So that's just a brief overview of R. I guess the programmers would be more interested in the details about the syntax and semantics and all that. Yeah. So these are like some advantages in using R. It thrives through a supportive community. You can make beautiful graphics with it. You can use it to create builds and web apps via R Shiny. And it's very, very good for statistics and data science. Yes. So it's actually a very useful programming language to know when it comes to data analysis. And it's also open source. So it's not like other tools where you have to pay to access like more functionality. It's open source. It's not machine dependent. So it works across platform. You can write a program on Windows with R, and then you can use it on Mac, on Linux. Yeah. So it helps with that. You can also, it allows with handling big data with parallel computing. Yes, so when you have really big data sets, R is, with some R packages, you can use parallel computing to work on that. So we have like, these are basic data types in R. Those who are familiar with programming would already know this, but for those who aren't, we have, it's simply like how data is represented in R. So for example, if I type this in R will recognize it as a character. Yes. So in Python, I think the equivalent is a string. So that's the same thing. And we have integers, we have numeric. Numeric is for data that has decimals. So that's for numeric. Logical, we have true or false. Complex, numbers, and then raw. So for the raw, the data is displayed as raw bytes. For whatever purpose you want to display your data as raw bytes, yeah, you can do that in R. So I think when we get into the studio and we have the practical session, these would be clearer. But in R, you're gonna store your data or your object as a variable. A variable is simply a name or tag that you give to the object. It's like how, say, if you go to the supermarket to buy biscuits, you can either have McVitie's, you can have Piccadilly. So McVitie's is like the variable. Piccadilly is also like a variable, but the actual object inside the wrapper is biscuits. So that's just how, for those who are totally new to programming, that's sort of how I can explain how variables work. And the same variable can be used for different objects. So let's say you can take the biscuit wrapper and rather wrap it around an orange, right? And in that instance, you have McVitie's on the outside, but inside this orange inside the wrapper. So now the variable is storing a different object. Yeah. So I hope that sort of makes sense. Yeah. These are operations that you can do in R. You can do like various calculations. So these are the operators that you would use. You can use these operators. I think my pointer is not showing. But anyway, those are the relational operators. And then these are the logical operators. And they are simply used to test for equality or inequality in your data. Yes, let's say you have two data sets and you want to compare to see how similar they are. You can use these operators. And then we have the assignment operators. These are used to assign objects to variables. So the first one is the most popular in R. And that helps because, you know, sometimes when you use equals, it can be confusing, as in, are you assigning a variable, or are you comparing two objects? Are you testing for equality? It can be confusing in some languages. So for R, we having this arrow-like thing helps. Yeah, so that's basically it for this. And then we have data structures. So data structures are ways that you organize your data in order to work with it. So we have the most common or the most basic one in R is a vector. You would be using vectors a lot as a data analyst in R. And then we have matrices, we have lists, we have factors, we have data frames and arrays. I didn't put arrays here because it's not that common to use. I'm sure for more advanced users, they would be using arrays. It's a two-dimensional data structure. It's sort of similar to a matrix, yeah. So some of these data structures can take in data of only one type. For example, vectors, you can't combine, let's say, a character data and a numeric data in one vector. And we have lists. Lists can take objects of various data types. So you can have characters, you can have complex numbers and all that in one list. And you can have other data structures also in one list. And then we have factors. So factors are like used for categorical variables. So let's say in your data frame, you have this column that has gender. So gender will be the factor, and under gender, we have commonly male, female. I know these days there are like other genders, but commonly male, female. So male and female will be the level, and gender will be the factor. Or let's say you have educational level. So educational level will be the factor, and under it we have primary, secondary, tertiary. So those would be the levels under that factor. Yeah. And then the most common one is a data frame. A data frame is like similar to a spreadsheet, and it has rows and columns. And the thing about data frames in R is that for every column, the number of items in every column must be the same. So you can't have one column with, say, 5 items and another column with 20 items. It's not gonna work for a data frame. You can replace the missing values with NAs, yeah, but then NA is also an item in R. So the columns must have equal items. And then you can't have, say, different objects of different data types in one column. So I can't have, say, this column that I'm titling column 1. And under column 1, I have a numeric object, I have a character object, I have a logical object, all under column 1. It's not going to work. Yes. But I think that's similar for other tools too. So this is just like a quote in R. Yeah. And as I promised, this is going to be very brief. The slides are going to be very brief so that we can have more in the practical session. So these are like references. The CRAN is like where we get a lot of R packages from. We have about 10,000 class packages in the CRAN. And packages are simply code that other users have put together to solve a particular problem. So we have like the tidyverse, which is a popular package. We have, say, 4cats package. Yeah, those are packages. So it's just somebody smart putting together code so that if you want to do that thing that his code or her code does, you don't have to type you don't have to code all of that yourself. You can just import his or her code from CRAN and use it in your script. Yes, so these are links for those who want to try R for themselves afterwards. And these are just like references that helped in my slides. So I'm going to switch over to RStudio, and we are going to look at examples of what we talked about. Okay. So
in the meantime, if you have any questions, please note them down, and I'm sure after her presentation, right, Boadiwaa is going to attend to them. So yeah, if you have questions, just note them down. You can type them in the comment section. Yeah, thanks.
Okay. So this is how RStudio looks like. I hope it's showing. Is it?
It looks good. It looks like half of the screen.
Okay.
Yeah.
Let me enlarge it a little. Okay. I hope that's better. Okay, so that's RStudio, and over here we have the. Let me see if I can get a pointer. But anyway, so this first part where you see the cursor blinking, that's the script editor. And the interesting thing about RStudio is that you can type scripts in other languages. So I can actually run Python code over here. I can run SQL. I can run, there's a list of stuff that I can run. I can go to File, New File, C. So I can actually run a Python. This thing is a script. I can run a C file, a C++ file, an HTML file, CSS, Python, SQL. So you can code in like different languages using RStudio. And there's R Markdown. There's the Shiny web app that you can also launch from RStudio. So yeah, that's the scripts area. And then beneath the script area is where the cursor is now, is the console. So this is where the commands actually run. And so whatever command you run in your scripts is gonna appear in the console and to show that it's actually running. And then to my right, this place is the environment pane, and objects that you store in the script and you run during your session are gonna appear in the environment pane. Yes, and beneath the environment pane, we have the files, the help and viewer pane. So over here, the files over here is just showing the files in my current directory. And the plots, any plots that we create over here, you're gonna have a preview of it here. And the packages, it's gonna show the packages that I have installed. And yeah, I've already mentioned packages. So these are like just code that people have created to help me in my analysis. So I've installed a few of them. Some are like basic packages, others you have to install afresh. And then we have the help area. So the help area, you can search for any topic or any package, and then you can get more help on it to how to use it. So I was searching for one, and that's that over there. And then we have the viewer. So the viewer is gonna display any tables that you create. Those are gonna appear in the viewer. So you're gonna see a preview of that in the viewer. It sort of works similar to the plots area. Okay, so so we are getting into it now. So maybe I should start with some shortcuts. So if I want to restart my R session, I can use Control-Shift-F10 for whatever reason. Maybe I want to restart my R session and start all over. So I can do that. And then there's the assignments symbol, which you can get with Alt and minus. So that's the assignment symbol. This is for those who are completely new. And then we have Control, Shift, and C to comment out a line of code or a block of code. So that will just comment it out for me. And then we have Control, Shift, M, which is gonna give me the pipe operator, which is a very common operator that you're gonna use in your data analysis. It's under the Margaret's R package. Yeah. And then let's say, so we can start assigning something. We're gonna say create our first object. So object 1, and then we're gonna say create a vector. So 2, 4, 5, and then we're gonna run it. So it appears in the console beneath. As you can see on the right-hand side, we see it in the environment. So the environment is gonna list every object that's available in your session. Okay, so let's say I wanna clear my console. I can use Control-L to clear my console. Okay, so that's just like some basic stuff. And let's say I wanna get my working directory to know where my files are gonna be saved at. So that's my current working directory. If I want to save it, I think I want to save it on my desktop. So I can use this command ZWD, and I can just, to save time, let me just copy and paste this. Okay. So I'm gonna change it to my desktop. And then let me see if I've actually changed my working directory. So yeah, so now we are in the desktop now. That means I can load files from my desktop. Okay, so we can try a package. So let's pick up some data sets from a popular package in R. So if you wanna, let's say you found a package in the CRAN and you wanna use it, you'd use this command, install.packages, and you just type the name of the package. But I'm not gonna run this package because I know I've already installed it. So I can come here to my packages and search for car data. So that's it right there. And since I've already installed it, I don't need to install it again, but that was just for demonstration. So I can just load this package, and car data has like data sets, that sample data sets for you to practice on. So it's a pretty useful package. So let's say we want more information on car data. I can come to the console and I use the question mark sign. That's a way to ask for help. So there's no documentation over here. Maybe I can just click on the package itself. Okay. So it will describe what car data is, but basically it's just like a combination of data sets that, so we can see we have like American Math Society survey data, we have US states public school expenditures, a number of data sets. So today I thought we could use the salaries data set because it talks about money and I like money. Yeah. So salaries, okay. So yeah, we've loaded our car data package now. We're gonna pick the salaries data set, and let's give our objects a name so we can give it data sets. That'll be the name of our object. So salaries. I think I should just maximize the screen. Okay, so yeah, so that's the salaries data set, and I can come here and check. We can just look at how the data set looks like. So it has the rank, the discipline, years since PhD. It's just talking about the salaries of university lecturers. Actually, we could just read it from here. Salaries. So yeah, as it's saying in the help pane, it contains the 9-month academic salary for assistant professors in a college in the United States. So we are gonna see what we can find from this data. It just has 397 observations, but I think that'll work. Okay, and so we can have a summary of our data. Just give a brief summary. And so in the console, let me increase it. It's showing us that in every column, it's giving us a brief summary. So this is a quick way to have a fair idea of what your data set is about. So these are the numbers for assistant professor, associate professor, professor. We have 67, so that means 67 entries were from assistant professors and so on. And then when we come to the numeric columns, the years since PhD, we have, it gives us like the median, the mean, the minimum, maximum, first quartile, and so on. And then when we come to the factor column, the sex, we have 39 females and 358 males. So let me take this opportunity to show us how we are gonna check for the column names. So we can just do that. And so these are the column names in our data set. And I brought this up because let's say you want to check for the class of a particular column. So let's say we want to know what type of data is in the sex column. So as we can see, it's telling us that the sex column is of the factor data type. So that's how you gotta check your data types. And we can have a look. Let's say we didn't want to go all the way to the environment pane to look at our data. We can just have a look at it with the head command. So that will give you like a number of rows to give you a sample of your data. We can actually modify this command further and give it a particular number. So it's going to show us the first 10 rows. So if we have head, then of course we have tail. So we can also look at the bottom 10, or we can say the bottom 7. Yeah, so these are last 7 entries in the data set. So it's just a quick way to like run around your data, especially if let's say you have a really large data set. I don't think you'd want to come to the viewer and now scroll all the way to the bottom or the top. You can just use that. Okay, there's another one called Glimpse, but for that one you need to load the Tidyverse package. We are definitely gonna load the Tidyverse package because like that's like an important package in R. Okay, so what can we do with this data set? Let's say we want to look at, first of all, let's see if we can clean the data a bit. because see discipline over here, we have B's and A's. I don't think that looks really nice because what is B and what is A? And when we come down, it's telling us that A is A stands for theoretical departments and B stands for applied departments. So I think instead of having A and B, we can actually change all the B's to applied and all the A's to theoretical. So let's see how we can do that. So here's where I'd introduce tidyverse. So like almost every data analyst who uses R uses tidyverse. And it's very good for like cleaning data and wrangling data and all that. So yeah, tidyverse is loaded now. So these are like the attaching packages or the sub packages under tidyverse. We have ggplots, which is very good for graphics. We have tidyr, dplyr, and all that. So we can just take a glimpse at one of them. Let's look at dplyr. So it's telling us that dplyr is used for data manipulation. And so we're gonna be using DPL. But here's the thing, once you load tidyverse, all these attaching packages are also loaded. So I don't have to load dplyr again. Yeah, so I can start working with that. So we wanna change our columns. Which column did I say we're gonna change? The discipline. Yeah, we're gonna change it and make it look nicer. Okay. So we're gonna take our data set, which is now our variable, which is representing the salaries data. So data sets, we're gonna pipe it to this function, which is called mutate. I already said that R is a functional programming language, so we use a lot of functions over here. So we're gonna use mutate, and we are gonna change that column, which is the year discipline. Okay. So discipline mutates, as it says, it's gonna mutate, it's gonna change it. So mutate discipline, and okay, I'm gonna need another package, which is the for cuts. Okay, it's already loaded. So this function that I'm using is a package under the tidyverse, and I'm gonna need it because I'm working with the fact. I'm sure the discipline column is a factor. I can check. So data set $discipline. So it's a factor yet. So FCT recode is gonna work for factors. If it was a character column, I can change it with a different function. Yeah. So FCT recode, and I think we're gonna use theoretical department. So theoretical department for A. Yeah. And I think we can add applied department B. Okay, so let's run this and see. I think I'm getting an error. Let's see. Okay, yeah, I didn't close. So wait. One sec. Let's find out why we are getting this error. Okay, yeah. So I didn't indicate which column it should work on. So yeah, that's why I think. Okay, so that's that. So that's what makes R a little confusing for new learners, because the code it's not as intuitive as Python. It's closer to machine language than it is to human language. So it takes a little bit of learning, but yeah, so that's that. So I can pipe this back to our original data set so that it changes it. So we can come check here. Then we see that applied we've changed that now. So yeah, that looks much more nicer than A's and B's. I guess we can also change the column names, and maybe we can bold in, we can capitalize them so that, because small caps doesn't look too presentable. Yes, so we could do that as well. So we can take the data set and so let me explain what this, why we keep assigning it back to the original variable. So whatever is on the right hand side is gonna run and it's gonna show in the console. But if you want it to affect the original data set, then you have to pipe it back to that same variable so that it changes it in the original data set. So that's why I keep doing that. So we're gonna okay, so we want to rename the columns. Rename. And we've already piped the data in. So actually, I can just use this function to change everything to upper. So then we can come and check, see that we've capitalized the column names. Okay, let's say I don't like how yours' PhD is written. Maybe I want something different. So we can also rename that one. So data set, rename. So you start with a new name. So I actually want it to be in like full instead of the shorthand. So yes is PhD. Oh, hold on. And then for the bottom part, we put the old one there. So that's yes. So you see these little boxes, you can just use tab to complete it instead of typing out the entire code. Okay, so we can go and check and see. Yes, so that's that. It looks nicer now. Okay, so I think we've done enough data cleaning. We are running out of time. So let's see what we can do. So we can, first of all, get like a summary, a table summary of our data. So let's come to table summary. Okay, for that, we are gonna need this package, the GT summary package. Okay, so let's table summary. Okay, it's running. Okay, so in our viewer, you can see that it gives us a brief summary of the data. So yeah, it's given us the percentages and the numbers, and it's a quick way to present. Let's say we can just call this an overview of our data. So actually we can give it a title. So again, we are gonna use a function because everything in R is done with function. So we're gonna call it general overview of the salaries data set. Okay, and let's run that. So yeah, it gives us that title. And I mean, there are lots of things that we can do. We can modify the appearance and make it look a little more fancy. We can actually hold in the labels. So let's see. So yeah, that broadens the labels and makes it more presentable. We can, let's say, look at the salaries column. I mean, the salaries row. It doesn't really look like money. So let's try and format it so that it looks more like money. So for that, we can use this function. And again, so a thing about R is that a lot of the things you're gonna do, you're gonna need packages. Because I mean, it's a functional language. So a lot of things you're gonna use functions, and people group these functions together under packages. So we can do that. We're gonna I'd want it to be in like 1 decimal place, and I'd want to use the $sign. So use the $sign. Okay. So this is a function, and to use our function, we can give it a name. So we can call it like the $function, so that we can use it in our formatting. So I can come here into table summary, and I mean, some of these are like advanced, but I just want to show, it might look confusing to beginners, but I just want to show some of the things we can do in R. So we can do the digits equals, starts with salary. Salary. And then we're going to use $function. And I'm sure like there can be, sorry, I didn't store this. As you can see, it's not in my environment, so I have to run it so that it gets stored. Okay, so now it's in the environment. I can run this again. Some of these functions, there are different ways to go about it. I'm sure someone might have a simpler way of doing this. Okay, so now we can go down and see that now it's in, it looks more like money now. So yeah, so that's for the table. We can color our table. I don't know how much time we have. I think we're running out of time. Yeah, so maybe let's do a graph instead. So for graphs, you use the ggplot package, and you can, for example, plot the sex, or let me see which graph can we plot. We can plot, say, the years since PhD versus the salary. So X can be years since PhD, and our Y will be the salary. And then we can maybe, yeah, we can actually even compare the sexes and then differentiate by color. So we are gonna color according to sex. And let's say we want a scatter plot. Okay, so let's see how this looks like. Oh, sorry. Oh, yeah, I didn't pipe my data. So I had to, my data set, I was just given a blank command. So I'm gonna have to pipe the data set. So ggplot. Okay, that should work now. Okay. Okay, so that gives us like our plots, but this of course doesn't look nice. So we can just modify it a little. And of course, I'm gonna use a package because I'm sure somebody has already done the work for me. So there's this popular package where you can get themes from. Yeah, so I'm just gonna use somebody's editing on my plot. So this is modeled after the Wall Street Journal, by the way. So yeah, so that looks like, but still I don't like the colors of the points, so I can do something about it. So scale, oh sorry, scale, color, shoot. And let's say I have the hex codes or even the name of a color that is loaded in R. I can use that, but manual. So let's say I want red and black. So values, so red values, red and black. Okay. Okay, so that changes the colors for me. Let's add a regression model and see how this data is behaving. So we want to see, are the salaries increasing or decreasing, because this looks like all over the place. So, so we want to add a regression model. Okay, so that's showing us that the salaries are actually increasing. And at this point, but you see the males are getting paid more, or is it the opposite? Yeah, the males are getting paid more than the females, even after the same number of years from the PhD. And we realized that around about 40 years post PhD, it's like we don't see females working, because I don't see any salaries for females after that. So that's just like some insights we can derive from our data. We can investigate further to find out why this is the case. And the gray ribbon around it is just the confidence interval. Yes, so we can actually take it out if we don't want it. So we can just modify our code a little. And we take that gray ribbon out. So, I mean, there are lots of things that we can do to our data, our graph and our tables. Let's give this a title. So we can give it a title. Maybe Resagratia session. And then we can have a subtitle. Data set from data package. Yeah. So I think at some point you're gonna have to stop me, because then I'm not I wouldn't realize the time is running. Okay, so that's that. Let me see if I can quickly run to our markdown so that we create a report and join the work that we've done. And then I guess we can call it a day. Yeah. There's more we could do if we had more time, because I remember our table wasn't looking too nice. We could have colored some areas and made some of the numbers stand out and changed the font and all that. But I guess maybe some other time. So
you're doing great. Yeah, that's all I can say. You're doing great.
Okay, so let's save this. So Resagratia session, and our documents are saved with a .r extension. That's just by the way. So we can just create a markdown file to create a quick report of what we've just done. So I think the author already inputted an author in Resagratia are warriors. And we can call this general overview of salaries data set. And the default output format is an HTML file, but we can save in PDF and Word. Yes, we can also make it into a presentation. So like my PowerPoint presentation, I could have actually done it with R. And yeah, that's for R Shiny and all. So we can just start with a basic, which is an HTML. Okay, so let's just, first of all, we can just run this and see what it gives us so that we have a feel of how it looks like. Okay, so our session. Okay, so it's gonna knit and we will see how a markdown file looks like. Okay, so it's creating a markdown file. I don't know if you can see because like, I guess I'll have to share this screen, but the report is ready. Can you see it?
No, just your R Studio.
Okay, so let me share this one. Okay, can you see it now? Okay, so that's just, we could just like include we could just copy and paste the code that we created. And then instead of this plot, you would have the plots that we created. And instead of this, we could have our table and all that. Yeah. And there are options to like take this summary cars, like the inline code out so that it doesn't show and all of that. But I don't know, it looks like we're running out of time. So maybe I'll pause here unless you give me the go ahead.
No, I think you were going to show us maybe adding a few elements that you already ran in the
okay, so that, yeah, okay, so we can create our reports. Okay,
yes.
Fine. Okay, so let me go back to our studio and let's see if we can create our reports. So okay, so we could actually add like a table of contents and all that. Maybe we should. So we can add table of contents. And then, okay, that's fine. And we can, this is how you create the title. So our title will be table. And this is just text, so we can just clear this out and say preliminary analysis of the salaries. Okay, and this is just showing our code. We can create this chunk with Control, Alt, and I. Okay, and we can just go and copy and paste our code. So our code started. Mind you, we have to include our libraries. Yeah, there's a way where you can just, instead of copying and pasting the code, you can just reference the script from our markdown, but I'm not going to that today. So we're gonna, first of all, copy our libraries. And by convention, we actually put this in the first chunk so that it loads all the libraries. I think we've left out the car data, so we can go pick it up. And then, okay, so that's good. We can come and get our, I'm just copying the important parts of the code that will get us our table. So this was when we loaded the data set into the variable. And I think with these, we already, like, it was just giving us an overview of the data, so we are not gonna pick those ones up. But the data cleaning aspect was important, so we're gonna pick that. So the rule is, I don't know if it's a rule. R is pretty flexible. As you can see, I didn't even indent my code and all that. By the way, there's a way I can do that. There's a shortcut for that. I could use Ctrl-Shift-E to indent my code. So let's say I could. I know if I was doing this in Python and I hadn't indented my code, it's gonna like throw up errors. But in R, I can't get away with that. It's not good practice though. You should indent your code so that it looks readable anyway. But okay, so that's for our table, and then we can copy the one for our graph. So this one is for our graph. And this is just like giving a title to that chunk of code. So I think we can take these ones out, and I can rather name this graph 1. This compares the salaries, males, and male and female professors. Yes, after their PhD. So let's mix that and see. One thing about R is that it can be a little slow. I think I'm running into an error. So it's has an error over here. HTML. Okay. Try and fix that. Okay. Maybe I should just. I think there was an issue with my indent that was running now. And it's a little slow. R is a little slow. That's like a disadvantage. Yeah.
I'm getting that vibe. I saw earlier in the I saw earlier in the comments that someone posted a link to our studio on the cloud. I think, you know, that could be one way to take advantage of in process there on the cloud.
Okay, so I can share the report. Yeah. So let me share the screen. Okay. So that's our report, and that's our table, and that's our graph. And I think we don't like these code chunks. I mean, you might want it, but I think it makes it look messy. So I can just slightly change the code so that all those code chunks do not
I think that's already looking great. It reminds me of a Jupyter notebook with markdown.
Oh, yeah.
Interesting. This looks really fantastic. Along with others, I included some comments as well. So, I mean, questions as well. So, when you're ready, Boadiwaa, we can.
Okay.
We can take some.
Okay. It's still knitting, so.
It's still knitting.
No, I mean, I took out all that verbose code, you know, like all those coders. So it's taking that out. I can actually take these warnings also out. I can just put message, false. But anyway, let's go to the chat and then see.
Wow, okay. This looks fantastic. Actually, Boadiwaa, this like this feature, this like seeing the final, you know how they say it's like the front end is always the right, pun intended, whilst the back end is like no one ever wants to reveal what's actually going on. You just showed us exactly that, right, in last couple of minutes. So fantastic stuff. Because of time, I would want us to take some comments like really quickly. The first one was about commenting, but I think that's already been answered. So I want to ask, hey, what does commenting out the code means? But I think that's been clear.
For the newbies, the total newbies. So commenting out the code is, let's say I type code and I don't want it to run when I run my script. So I can just comment out that section so that when I run my scripts, that part of the code doesn't run. But I see there's someone in the chat who's already answered some of the questions, so I'm really happy about that.
Oh, I know, it's been very engaging, you know. Someone asked, why do you skip certain numbers, right? Like in terms of your, in the editor, like you code on line 15, then you skip 16 and code on 17. I mean,
just to create some space so that my code looks readable. Okay, because then if I finish, like let's say I type out code for one particular thing, and then I type out code for a different thing, and I join the two together. If somebody is reading my code, they might get confused. So it's just for readability. Actually, I'm supposed to even indent some more. If I was doing this in Python, I'd have been cancelled. But yeah, so the spacing is just to, you know, like improve the appearance of the code. Yeah.
That's super. Another one which I asked, and I think it's also been answered, but please, it's like, how do you type the percentage and greater than a percentage so quickly? Because I tried it, I was like,
so there's a shortcut. It's Control plus Shift plus M.
Wonderful. Yeah. So if you're like me and you're wondering how is she acing, like everything just seems like really quickly typed. So yeah, Control Shift and M. And Ashanafi is asking how do you type the assignment operator so quickly?
So that's Alt plus minus.
Alt plus minus. It's like, okay, Alt is more reachable, easily reachable. Okay. Another question is ggplot what we use to make charts, like a visual. I think that's been answered too.
Yeah.
All right. And I had a question, right? Looking at this, and I'm like, hey, can we add this HTML file, right? This generated one to our portfolio? Because I assume if you share this r session.html file with me, I run it on my browser, I would see exactly the same thing. I don't need to be connected to the internet, do I?
Yes. No, because the good thing is that you just the HTML. Yeah, the HTML is like the finished product. So yeah, you don't even need the code to have it. I guess if you want the code, you mean the markdown file, like the one we used to generate the HTML. So for that one, you can run it and you can get the HTML file. Because remember our data sets is already installed in R. We're using a package in R for our data. Do you get it? Let's say if we're using my data set, like my own personal data set on my PC, then you wouldn't get the original data to run and produce this. Does that make sense? Unless like that data there's a way we can share that data. Maybe, for example, if it's on the cloud, or if you also have that data, then you could get this output. Yeah, but I mean, there are ways to go about that. Yeah.
Fantastic. And there's a general question here from Mary. She's asking, how long did it take you to learn R?
Okay, Okay, so I had to learn how to work on a project. So I think I took about, for the basics, I took about 2 weeks. I'm still learning, so I learn more every time I'm working. And also I work in the hospital, so I guess if I was doing our full time, then it would have probably taken me less to learn it. So it's actually not too difficult to learn, really, once you get the basics.
Hey, you mentioned one
word. The truth is that Python is easier. Python might be easier for some people, just because Python is more understandable to humans, right? But
it's
still
human readable.
Yeah.
I heard one word you mentioned, hospital. So working in a hospital, like how, maybe it's only me that's curious, but perhaps somebody else could learn as well. How are you managing how are you managing data and this and research and hospital? Like,
okay, so when I close from the hospital, I code if there's code to be written, I do that. And I think my internship, so the organization I'm interning with, they are pretty flexible because it's a science organization, and so they understand. And we've got like a few doctors here, more in like administrative roles, yeah. But I mean, they understand that I can't be at work every day, so I come as often as I can. And then I take on like freelance client projects. And so that also keeps me, I think the good thing about internships and freelancing is that it keeps you improving your skills, even when you don't feel like it. Because let's say my client wants me to deliver by tomorrow, no matter how tired I am, I'm gonna stay up and code. Yeah, so that helps keep me learning.
That's great to hear. That's great to hear. I have to say that this session was extremely empowering. And I had a good time. I think the audience as well had a very fantastic time. There are a few more questions coming up, and I'm just looking at time here, and I'm thinking, hey, have to take a rain check on that so we don't extend the limited time we have for this. But Boadiwaa, thank you so much. This was fantastic. Somebody else is asking in comments, are you a medical doctor? Hey,
yes, please.
So yeah, you heard it from her. This was a fantastic experience for me. And I started learning R at some point, and I out, right, for sure. I picked up other skills, and it's like sometimes you learn whilst you're on the job, and you learn really quickly, right? Yeah. So for you, it's what is being displayed in your experience here. So lovely to see this R markdown HTML feature, and it's something that I would really like to try. So yeah.
It's very, I mean, our one thing our beats Python adds is the graphical stuff, the presentation. R is very good at that. So I mean, there's a lot more that we could have done if we had more time. We could have experimented with the appearance of our tables, our graphs, the output formats. Yeah, it's not only HTML. We could create a PDF out of it. We could have created Word documents. Could have created slides, different kind of slides. So yeah, it's pretty interesting. Yeah.
You heard it from her. So yeah, I think everyone should have a go at it and crack on. And if you haven't already, please, it would be good to get your feedback. It's going to help us design a better experience. I added the link in the comment section and chat section. Please have a look. And of course, follow Resagratia for more content like this. Paulina Boadiwaa Mensah is on LinkedIn, so look her up. You can't miss, right? Definitely can't miss. Yeah, I don't know if you have any final words.
I'm just glad that we had fun and we could create something little. And thank you all, especially the engagement in the chat section was pretty interesting. I'm now reading some of them. Thank you to my helpers who were answering some of the questions. And thank you for coming. Hope to see you soon, if not here, somewhere. Yeah.
All right. Thank you very much, guys. Cheers, Boadiwaa.
Bye-bye.
Bye.